Hello everyone, welcome to another session of Financial Maths in the Wisest King Academy. I am Dos Solomon and it's always a pleasure reaching out to you with a new content. Today we will be working on annuities. Please, if you're new, you're highly welcome. Subscribe to the channel and hit the notification bell. And please, if you also find this video interesting, do not forget to hit the like button. I'd like to greet you watching from Cameroon, watching from Nigeria, watching from Ghana, from Sierra Leone, from Tanzania, from South Africa, from Cote d'Ivoire, from Congo, from Algeria, anywhere here in Africa, or you're watching from Europe, you're watching from Asia, you're watching from America, I greet you. Thank you very much, and please do not forget to share the video. Today, we will be working on annuities. Annuities is one of the most practical topic, whether in your life as an individual or in the life of businesses. Why? First of all, let's look at what is an annuity or what are annuities. Annuities are regular deposits or regular payments made either to constitute a capital or to reimburse a debt. Now, when we talk about regular deposits or regular payments, it means that these payments or these deposits are made within specific time interval, maybe monthly, maybe quarterly, maybe annually, maybe weekly, maybe daily. So you see, businesses do keep aside money, maybe to replace their fixed asset at the end of their useful life. We call this money depreciation. Or maybe to you save money. This money may be fixed or variable, but you have an engagement that every month or every day or every year or every quarter or every semester I need to save something. These money saved within this time interval, they are called annuities. And why do you do that? Either to constitute a capital or to reimburse a debt. Now, today in this video, we are going to see the various types of annuities and see how to calculate the present, the acquired value, of an annuity. So, what are the various types of annuities? There are actually two groups of things that we use to define the two types of annuities that exist. What are they? The first thing, an annuity may be constant or variable and at end of period or beginning of period. Let's get that. An annuity may be constant or variable. It may be at end of period or beginning of period. So let's start with the first one. Constant annuities. Annuities are constant if the amount set aside every period is constant, is the same. For example, every month I save 1 million, or every quarter I save 10 million, and so on. So, fixed amount, they are constant annuities. But now, being constant, it may be at end of period or beginning of period. So, annuities being variable, to ease our study here, and our understanding will assume that they are constant either in arithmetic progression or in geometric progression. That will be seen in later videos. For now, we are working on constant annuities. Now, let's look at the first type, end of period. End of period annuities. End of period is also called ordinary annuities. Now, what are end of period annuities or what are ordinary annuities? I would like you to also note that there are three things used to define whether an annuity is at end of period or at beginning of period. And behold, the difference between the two is 1 period. Beginning of period is more than end of period by 1 period. Now let's go. End of period annuity. Annuities are said to be at end of period if the first annuity or the first deposit or the first payment is made a period after the contract is signed. That's the first thing. First annuity, a period after the sign of the contract. Number 2, the acquired value is calculated immediately the last deposit is made. That's at period end. Immediately the last deposit is made, the acquired value is calculated. And the third, the present value is calculated a period before the first deposit. I repeat, an annuity is at end of period, or an annuity is ordinary if the first deposit or first payment or first annuity is made a period before the sign of the contract or the decision is made. The acquired value is calculated immediately the last deposit is made, and the present value is calculated a period before the first deposit. So let's consider these notations, right? Let A be the constant annuity. Constant annuity. Let N be the number of annuities. Number of annuities. Let I be the interest rate for one tranche CFA. That's R divided by 100. Let A be the acquired value. And let capital P be the present value or the actual value. There is an important aspect of annuities, it's called number line. Now let's get this. I'm going to remove everything I said as per the definition of the type of annuity. You have 0, 1, 2, 3, N minus 1 and N. N minus 1 means one period to the end. So if N is 10, N minus 1 is 9. So we have here A, and A. Here we have B, and here we have capital A. Remember, if we leave from here and going like this, we are compounding. And if we leave from here and coming like this, we are discounting or actualizing. Leave from here going this way, we are compounding or capitalizing. Leave from here coming back, we are discounting or actualizing. Okay, here we said an annuity is at end of period if the first deposit or first annuity is made a period after the contract is signed. The contract is signed at period 0. So you can see the first annuity here. Now we said the acquired value is calculated immediately the last deposit is made. You can see that. Right? And technically it means that this last deposit does not generate any interest since it's made at end of period. Now the present value is calculated a period before the first deposit. Generally, the present value is always calculated when the contract is signed or when the decision is made. But now when the first deposit is made, it determines the time of annuity. If I take the decision now and I start depositing at the end of the period or next period, that's end of period. But if I take the decision now and I start depositing now, that's beginning of period. And that's actually why the difference between end of period and beginning of period is 1 period. Okay, we have this. Let's see. Calculation of acquired value. Calculation of acquired value A. This is nice. The acquired value of ordinary annuity is calculated immediately the last deposit is made. Number 1, this means that the last deposit or the last annuity does not generate any interest, and that is going to be proven. And now it is actually calculated by compounding the individual annuities to the last period. So all of these annuities are compounded to the last period. To the last period. Meaning that what? It is actually the sum of the acquired values of the individual annuities. Now let's go. Let me put this on the board. Here we have N. It may be difficult for you to understand with N, but now let's assume we are dealing with 5 annuities. 0, 1, 2, 3, 4, and 5. So this is A, and A. Now we want to calculate the acquired value. We have 5 periods there. Let's call it 5 years. Now you discover that this one is going to be compounded to the 5th period. Now we can count the number of compoundings. 1, 2, 3, and 4. So the first annuity will be compounded how many times? 4 times. So this one will be compounded 4 times. Right? permit me to bring it this way. So this will be a into 1 plus I raised to the power 4. This one will be compounded how many times? 1, 2, 3. A into 1 plus I raised to the power 3. This one will be compounded how many times? 1, 2. This is A into 1 plus I raised to the power 2. This will be compounded how many times? 1 time. That's A into 1 plus I. And look at this one. Do we compound it? No. We do not compound because it is already at the last period. So it means that this acquired value is the sum of this, and this. We calculated it by compounding these individual annuities to the last period, which is the peak period. So, if you notice something technically, the first annuity will go for 4 periods. But the total periods available is how many? 5. So, if I want to calculate the period of each annuity with respect to the last period, look at it. If I take 5 minus 1, that's going to give me 4. If I take 5 minus 2, that's going to give me 3. If I take 5 minus 3, that's going to give me 2. If I take 5 minus 4, that's going to give me 1. And 5 minus 5, 0. Anything raised to the power 0 is 1. So you can now see that the last deposit does not actually generate any interest. So let's generalize it here. Now here, the acquired value here will be what? A into 1 plus I raised to the power n minus 1. Like here, the first one was what? 5 minus 1, which is 4. So plus A into 1 plus I raised to the power n minus 2 plus A into 1 plus I raised to the power n minus 3 plus plus A into 1 plus I, because this one, you go one time. Now plus A. The last one does not generate any interest. That's why we have it that way. Now, if we classify these terms, beginning from the last one, we are going to have big A equals to small a plus A into 1 plus I plus plus A into 1 plus I raised to the power n minus 3 plus A into 1 plus I raised to the power n minus 2 and plus A into 1 plus I raised to the power n minus 1. Very, very important. If we look at it critically, these terms follow an increasing geometric progression with first term A, common ratio 1 plus I. So it means that this will be like AR n minus 3, AR n minus 2, AR n minus 1. If you look at it critically, this is actually the nth term of a GP. Now, if we want to sum all of them, how do we calculate the sum of the first n terms of a GP if the common ratio is greater than 1? A into R raised to the power n minus 1 divided by R minus 1. And our R here is 1 plus I. Our A is TA. So Sn is like the total annuity. So we're going to have something like this. A into A still remains. Now R is 1 plus I. 1 plus I is already greater than 1. That's 1 plus I. So raised to the power n minus 1. Now we come down. 1 plus I minus 1. I will be left. So this is the formula to calculate acquired value at n of period, right? The formula to calculate acquired value at n of period. We are going to take some series of examples and see how to actually punch the calculator and calculate the acquired value. There is this thing you need to know. To calculate the acquired value, the frequency of the deposit or the frequency of the annuity must be equal to the frequency of the compounding. What do I mean? If you are given annual compounding and you're making annual deposit, then it matches, you can calculate. But if there is a difference, you need to make it to be the same, right? You are going to calculate the equivalent rate that matches the frequency of the annuity. Very, very important, because if you do not do it like that, it is not actually going to be possible for you to calculate. We are going to see how that functions here. Example number 1. Suppose a man deposits 200,000 francs in his account at the end of every year, right? So it means the constant annuity will be 200,000 francs. The constant annuity will be 200,000 francs. At the end of every year, at a compound interest rate of 5% compounded annually. So I will be equals to 5%, which is 0.05. Now, if he makes 10 deposits, right? What should actually be his acquired value at the end of 10 years? So he made 10 deposits. So the first thing we need to identify is that he deposits the 200,000 at the end of every year. Compounding is 5% per annum. So you see, the frequency of the annuity equals the frequency of the compounding. So we can calculate. Let's apply our formula. A is equals to, now we are going to have small a, 1 plus I raised to the power n minus 1 divided by I. So we are going to have 200,000, 1.05, 1 plus 0.05 is 1.05. Now raised to the power 10 minus 1 divided by 0.05. So what is going to be the acquired value here? I'll start by punching this, then I multiply by 200,000. So I'm going to have 1.05 raised to the power 10 equals to minus 1 equals to divided by 0.05 equals to, then I multiply now by 200,000 francs. Okay, it means for 10 deposits, the man is going to be having 2,515,578.507 francs CFA. Now this is his acquired value. Now let's see how much interest he has generated. To calculate the interest, take the acquired value minus the sum of the deposits made. So he made, let's say NA. So this will be 2,515,578.507 minus 10 times 200,000. 10 times 200,000 is going to give 2 million, which we subtract from 2,515,578.507. We are going to have a total interest of 515,578.507 francs CFA. This is a practical example. You can see the interest rate is just 5%. Now, you can go to your bank and you ask the question, how much will I gain as interest? Or ask, what is your interest rate? And do you calculate interest annually or semi-annually or compound monthly? Once you get that information and you know how much you want to be depositing at the end of which period, I tell you the truth, you'll be able to calculate your acquired value. Now, if you look at this person, he's already having a total interest of how much? 515,578, right? 578.507. How many years? 10 years of deposit. How much did he actually deposit? That's 2 million. So this is it. Now, in a case where we're going in a case where compounding is done more than once a year. If compounding is done more than once a year, our acquired value formula can be modified as follows. A into 1 plus IC raised to the power NC minus 1 divided by IC. Now, what is IC? IC is the proportional rate, which is simply I divided by C. Now, like to say that if compounding is done quarterly, divide your annual rate by 4. If it is done semi-annually, divide your annual rate by 2. Now, I'm still going to take an example now where the periodic deposit is made more than once a year and compounding is also equal to the frequency of the annuity. Let's assume that Mr. Doe is depositing 200,000 francs in his account at the end of every month. This is 200,000 francs CFA. At the end of every month, right? He does that for 5 years. 5 years. At the rate of 6% compounded monthly. So we have 0.06, right? This is the annual rate, 6% compounded monthly. It therefore means that the 6% is the annual rate, but compounding is done monthly, right? So we need to calculate the monthly proportional rate in this case. So in that case, small c will be equals to 12, number of compounding periods per year. So we want to calculate our I12, that's our proportional monthly rate. That is going to be I divided by 12, which is 0.06 divided by 12. And this is going to be 0.005. Come on. Let me confirm the calculation. 0.06 divided by 12. That's 0.005. I'm correct. Now, what is going to be the acquired value here? The acquired value formula will be modified as thus: A into 1 plus I12 raised to the power 12n minus 1 divided by I12. Now, the issue is this: I12 is the monthly proportional rate. 12n is the number of months in n years. That's the number of periods, monthly periods in n years. So we can now calculate. Now remember, the frequency of the deposits monthly is equal to the frequency of the compounding monthly. So we can calculate. So this is going to be 200,000 into 1.005 raised to the power 12 times 5 minus 1 divided by 0.005. What is going to be the acquired value there? Come on, let's get it. 1.005 raised to the power 60, because 12 times 5 is 60 equals to minus 1 equals to divided by 0.005 equals to times 200,000. We are going to have 30,954,000, 30,954,000 and 6.1 francs CFA. You see, in 5 years, if you are making monthly deposit of 200,000 francs, in 5 years, the total amount that you have acquired is this. Let's look at the total interest generated. The total interest will be the acquired value, which is 30,954,006.1 minus, we are going to take the number of deposits, 60 times 200,000. 60, if I remove this 0 and add here, it becomes 2 million. 6 times 2 million is 12 million. So 12 million from 30,954,000. You discover that in 1 year time, this person has made a total interest of 1,954,006.1 francs CFA. So that's the total. Wow. So you see, and please, these are practical examples. You can go towards your bank, you discover that they will give you interest rates that are almost similar to this. These interest rates are not exorbitant, they are just practical interest rates. So if you go to your bank and you ask that question, I assure you, you'll be able to calculate how much interest, what will be acquired value, and how much interest you must have generated in that period. So this is a situation where the first scenario and this scenario, the frequency of compounding and the frequency of the annuities are equal. Now let's look at the case where the frequency of the annuity is different from the frequency of the compounding, and see how we go with that. I'm going to formulate the same question similar to the previous one. Mr. Doe deposits 200,000 francs in his account at the end of every month. A equals to 200,000. Right? He does that for 5 years. N equals to 5 years. At the rate of 6% compounded semi-annually. So small c is 2. Small c is actually 2, right? Compounded semi-annually. You discover that the annuity is made at the end of every month, but compounding is done semi-annually. There is a difference. So how do we go about that? We need to calculate the equivalent monthly rate, right? But before we do that, we need to calculate the semi-annual proportional rate. That is 0.06 divided by 2, which is 0.03. So we need to calculate the monthly rate equivalent to a semi-annual rate of 3%. We are going to use this formula. So I will just put the number I want so that you understand easily. This is I12 equals to 1 plus I2. We play at this level. So this will be 2 divided by 12 minus 1. So if I look at this, I'm going to have 1.03 raised to the power 2 divided by 12 minus 1. So I12 is going to be, now I'm going to start at this level. 2 divided by 12 equals to, then I take 1.03 raised to the power answer equals to, now I'm going to have a rate of 0.00494. Let me end it at that level, right? So I could still end it at 0.005 because 49 I could end it at 5, but let me end it at this level. So this is the monthly rate. Now the equivalent monthly rate to this semi-annual rate. So having now my monthly rate, my monthly annuities, I can now calculate. Now this is going to be my acquired value A into 1 plus I12 raised to the power 12n minus 1 divided by I12. So this will be 200,000 into 1.00494 raised to the power 12 times 5 minus 1 divided by 0.00494. What is going to be the acquired value there? Let me calculate. So I'm going to have 1.00494 raised to the power 60 equals to minus 1 equals to divided by 0.00494 equals to times 200,000. 13,928,000. 13,928,216.61. So it means that the interest will be 13,928,216.61 minus 60 times 200,000. So minus 12 million. So you have 1,392,000. Sorry, 1,900,000. 1,928,216.61. That is going to be the total interest generated. So I believe at this level you are able to calculate the acquired value. Please, I'm going to drop the link of my lecture on compound interest where you calculate the equivalent interest rate. So like what we did here, right? So these are mostly the way complicated questions will come in annuities. So like I said, the frequency of the compounding depends on your financial institution, but the frequency of the annuity depends on you, the annuitant or the client. So most of those things will likely vary, so you need the equivalent rate. So I believe at this level you are able to calculate the compound interest on an annuity and also the acquired value. Thank you very much for watching. I hope you find this video useful. Please do not forget to share the link.